welcome back to some more geometry. Today we are talking about angle relationships. So, the objective for today was the student will be able to use the relationships of complementary, supplementary, and perpendicular angles to solve for the given unknown. So, last week we talked about three specific types of angles. We talked about adjacent angles. Adjacent angles are just angles that are next to each other. They don't have any necessarily relationship at the moment. They can be completely different, and it's fine, but they are adjacent. They're right next to it. They share a common side. We talked about complementary angles, not complementary, sorry. We talked about congruent angles, angles that are congruent. The best example were vertical angles. Vertical angles are a set of angles that are formed by two lines intersecting, such that the angles across from each other are vertical. So these two angles that are double marked and these two angles are single marked, they only share that one point in the middle. We then talk about linear pairs. Linear pairs are also adjacent angles, but they form to be 180 degrees together. So I may not know the value of angle 1 right here or angle 2, but I do know that together they form a straight line and they equal 180 together. So we're going to speak on some more special relationships happening here. So the first one is complementary angles. Complementary angles are two angles whose sum equals 90 degrees. Now, they can be adjacent angles like this one, where 40 plus 90 equal 180. Or they can be in a triangle. So, for example, a triangle, the sum of a triangle equals 180. This is a right triangle, meaning one of the angles is 90, so the other two angles together equal 90. So these two angles are complementary angles. They can also be completely separated, but the sum of these two angles are still 90 degrees, so they're complementary angles. So the first problem right here, given that this triangle forms a right angle right here in the middle, what is the value of x? So if you had to set up a problem, the best way to kind of set this up is saying x plus x plus 37, those are the two angles, equals 90. We then go ahead and subtract our 37, we end up finding x to equal 53. So 53 is the value of our angle right here. So that's complementary angles. Just two angles that equal 90 degrees. Whether they're adjacent or not, that's the value. The other one is supplementary. Oh, and real quick, on complementary angles, the shorthand is COMP, comp angles. You can write that like that. Say, hey, you're talking about complementary angles. The next one is supplementary angles, or sub-angles right here. They're two angles whose sum equals 180 degrees. So, for example, these two angles right here, 50 and 130, they equal 180. So they're supplementary angles, even though they're not touching or next to each other. But most of the ones you will see are linear pairs. Like we said earlier, linear pairs are just two angles who are right next to each other that equal 180 degrees. So all linear pairs are supplementary angles, but not all supplementary angles are linear pairs. So that being said, this is actually a word problem that you had earlier, or you will have. Actually, in the previous book we used to have it, and I kept it in here. But the word problem is saying you have a pair of linear pair angles. Linear pair angles. One angle is 54 more than the other angle. Period. Oh, excuse the bell. The question is, what are the two angles? So you're trying to find the value of the two angles. Now, when you get a word problem like this, it's really bad. It's a really bad habit to be like, oh, well, one's 54 and the other one's something else. No. One angle is 54 more than the other angle. So if you know, when you have something like that, especially when you have an other angle, we always call our other angle, let me put that in parentheses, quotations, to be our smaller angle, our x. The first angle is 54 more than the other angle. So we got to take the value of the other angle, our x, and add 54. A lot of bad habits that happen sometimes is we'll just say x plus 54 because we have the angle plus 54 equals 180. Understand, this is incorrect because we're only including one angle. This is one angle right here. We have to include the other angle. So don't forget that. All right, so this is our problem. We got x plus 54 equals 180. Now you can assume it equals 180 because they are a linear pair. Like we said, linear pairs equal 180 all the time. So when I add these up, I get 2x plus 54 equals 180 degrees. And then subtract 54 minus 54, we end up getting 2x equals 126. Divide by 2, divide by 2. X equals 63. Now, the other angle happens to be 63. So x plus 54, right here, that ends up being 117. Now, we get 117 because it's 63 plus 54. That gives us 117. All right, in the homework today, you're going to be doing a lot of word problems. They're going to give you just the word problems. It's your job to kind of draw something out to kind of imagine that. And go in the way they mention it. There's a problem that we're going to talk about next. That's the first one in your homework. And we'll go over that at the end of the video right here. All right, the last of these. So we talked about complementary angles, two angles that equal 90. We talked about supplementary angles, two angles that equal 180 together. And our last one is perpendicular lines. So this is about the line specifically. And not just the line specifically, but the intersection that happens of these lines. So when these two lines intersect in a certain way such that it forms a right angle, or 90-degree angles, you get what's called perpendicular lines. That's their name. So if I have one right angle right here, how many right angles do I have in total? Anybody? Anybody? Yeah, 4. We have 4 right angles right here. So I got 1, 2, 3, 4 right angles right there. That happens when you have one perpendicular angle. Now, when it talks about the other part right here, it says also used for intersecting rays and segments. So these are rays. You got 2 rays that happen to intersect. We'll call one A, B, and C. See? And there's a random point D over here. Okay, these two rays intersect to form a right angle, and this D value right here was just drawn out to split this up. So I have 2 new angles right here. Now, I don't know if they're equal or not, but what I do know is that those 2 angles together equal 90 degrees. Okay, they're complementary angles because they are bound with inside the right angle that is formed right here. So, keeping that in mind, when we look at this problem down here, you got to understand these 2 angles right here have that same value as these. They're bound within the right angle. We know there's a right angle because it tells us there's a right angle. So it forms 4 right angle. And this right angle over here, the bottom right, is due to the fact that it takes both of them together. So go ahead and find the value of x and y where we convene. Pause for a second. All right. So first let's set up the equations. For x, we'll say 2x plus, 2x plus 5x plus 6 equals 90 degrees. They equal 90 because we said, hey, that's a 90-degree angle. And combine like terms, you get 7x plus 6 equals 90. We subtract our 6 to both sides. We end up having 7x equals 84. You divide that, you end up getting 12. 12. Okay, so that's our x value. That's what we're looking for, the x value. That's a 7. Okay, for our y value, similarly enough, we will say for y minus 2 equals 90. Now, we know that equals 90 because if its neighboring angle is 90, its supplement over here, which is a linear pair, also 90. We add 2, we add 2, we get 4y equals 92. We divide by 4. Maybe, there you go. Divide by 4, divide by 4. We end up getting 23 for that. 23. All right. Last thing right here, example, and then we're done with this section. All right, so we got 4 questions here. We got these 3 right here, and this one at the end. And your job is to determine, 1, is the statement true or false? Oh, I misspelled that. Should be an E right there. Statement. Nobody caught that all day. That should be a statement. Determine the statement is true, and then if it's not true, tell me a reason why it's not true. So let's look at this. So this first one, 6 and 8, they are complementary angles, true or false? The answer is yes, they are complementary angles. Now why? Well, the only given information here is that this is a right angle right here. So that's a right angle. Like we said, when 2 lines intersect, it forms 4 right angles. So these 2 together will make a right angle. So yes, they're complementary by definition since they both equal 90 together. Now, is 7 and 8, angle 7 and angle 8, a linear pair. So this angle right here and this angle right here, are they a set of linear pairs? The answer is no. They're not, because there's this gap right here. There's this angle 6 that kind of keeps us separated. And like we said, linear pairs are two angles adjacent next to each other. These two angles are not adjacent, so we can't say they're a linear pair. Good, good, good. The next one will be angle 2 and angle 4. Are they vertical angles? Yes or no? The answer is yes. They're vertical angles because they're right across each other. Like we said earlier, two lines intersect such that the adjacent angles, the angles that share only one point across from each other, or the way we say across from each other, they will always equal each other. They will have the same value. Remember, vertical angles, it's always assumed when two lines intersect. Good. The last one here, I'm going to erase this so we can kind of see a little better. The last one here says, does angle 9, the measure of angle 9, equal the measure of 6 plus angle 8? So this angle, these two angles added together, I'm going to do 3 on this one. So yes, these two angles together equal this one angle, because like we said earlier, when these two lines intersect to form a right angle, it forms 4 right angles. So these two together make 90, and 9 by itself makes 90. So that's a yes on that one. Hopefully that helped. Homework is on Canvas, and I'll see you on a different day. Bye.